Use of AI-enhanced optical character recognition and machine learning for data processing in the Household Expenditure Survey, HES, 2023. In Singapore, the Household Expenditure Survey or HES is conducted every 5 years. Detailed information on households' expenditure are collected via questionnaire and expenditure diary recording, where members aged 14 years and over record their expenses for 2 weeks. As the expenditure recordings were in free text, the assignment of expenditure code to each expenditure description submitted by respondents was required for expenditure analysis by types of goods and services. Prior to HES 2023, this was done manually by our data processing clerks using an online dictionary. For hard copy booklets and receipts, our data processing clerks also had to manually enter the expenditure amount for each item into the system. With thousands of households submitting multiple receipts and booklets, it took a lot of time and effort to process the data collected. The manual coding process was also more prone to transcription errors and was less consistent, as each clerk might assign a different expenditure code to the same expenditure item. To overcome the massive time and effort demands of data processing, we have redesigned our processes and introduced automation initiatives for HES 2023. Firstly, we have improved the internet submission experience to encourage more self-enumeration for more electronic-based returns. For hard copy returns, we leverage AI-enhanced optical character recognition to convert them into machine-readable text. Machine learning, neural network classification model with NLP, is then used to partially automate the expenditure coding process. The Internet Submission Portal was enhanced to encourage more self-enumeration for more electronic-based returns. The portal was enhanced with a website tour function, including a step-by-step recording guide. Using a sample expenditure recording, the level of details required for recording were highlighted. Expenditure prompts for common vague descriptions were also built into the system, to ensure that the details of the self-enumerated records would be sufficient, even without guidance from a trained enumerator. Summarizing the overall data coding pipeline, hard copy returns were first scanned, processed through OCR and verified for accuracy. They were then combined with the electronic textual returns and fed into the machine learning model for assignment of the expenditure code. The outputs from the ML model were then returned to the data processing system for data processing clerks to further edit or code the record. The ML model reduced manual coding significantly and improved consistency in code assignment. The model assigned expenditure codes for 53% of the expenditure descriptions, with greater than 90% accuracy, and recommended expenditure codes for 19% of the expenditure descriptions, with about 75% eventually assigned codes within recommendations.